Now our last bit of work for acids and bases involves writing equations. But first of all, just a recognition of properties of acids and bases. Quite often we come across acidic properties of oxides, acidic and basic properties of oxides. Well, if it's a non-metal oxide, the solution formed if dissolved in water is going to be acidic. So any non-metal oxide is going to do the same. So if it's an oxide of nitrogen, it dissolves in water. Nitrogen dioxide dissolves in water to form nitric acid. Carbon dioxide dissolves in water to form carbonic acid. And that one is responsible for the acidification of the oceans at the moment. The extra carbon dioxide we're releasing into the atmosphere is dissolving in the oceans in greater amounts, meaning the oceans are becoming more acidic, and everything that relies on calcium carbonate for structure is suffering. Sulfur trioxide dissolves in water to form sulfuric acid. Sulfur dioxide dissolves in water to form sulfurous acid. So any non-metal oxide does the same thing. So oxides of phosphorus do the same, etc. Metal oxides, on the other hand, are basic. So sodium oxides, metal oxides are insoluble, so they need to react with water before you get any acidic and basic solutions. So sodium oxide reacts with water to form sodium hydroxide. Calcium oxide forms calcium hydroxide. So metal oxides are basic. Okay, now on to the basic reactions of acids, the essential reactions of acids, I should say. So, three basic classes of reactions that we look at. First of all, acid plus metal gives salt plus hydrogen gas. That's a reaction scheme. You'd all be familiar with that, I'm sure, from some point of your science career. Classic example of that is where you dissolve magnesium in a solution of something like HCl, dilute HCl, excuse me, it produces bubbles of gas which you then ignite coming out of a test tube and it goes pop, the old pop test. Okay, almost all metals, most metals react with acids to do the same thing. Always acid plus metal gives salt plus hydrogen gas. Now this is not actually an acid-base reaction, this is actually a redox reaction, which is the next chapter we do. However, it's such a classic reaction of acids that we included here. So any metal, any acid, virtually. So magnesium, metal and nitric acid. So acid plus metal gives salt plus hydrogen gas. Well, we know that the hydrogens in the acid are going to go off and form the hydrogen gas. So it's going to be the metal and the anion from the acid which go together to form the salt. Now you know that the charge on a magnesium ion is 2+. You also know that the nitrate ion is NO3-. So you can correctly write the formula of magnesium nitrate, of the salt, because you know your valencies. Very useful thing to know ions and their charges. Second type of reaction is actually an acid-base reaction. The carbonate acts as a base. So acid plus carbonate gives salt plus carbon dioxide plus water. Sodium carbonate and HCl, classic example of that. So carbonate, sodium carbonate, our acid HCl. All the H's from the acid and the CO3s from the carbonate give you carbon dioxide and water. Then the cation from the base, the anion from the acid combine to give the salt. And the last of our three basic classes of reaction, acid plus base, gives salt plus water. So, sulfuric acid and sodium hydroxide being our example, if you can write the formulas of each of those, it's pretty easy to see what's going to happen. So sulfuric acid is H2SO4, and you need to know your basic inorganic acids. So sulfuric, nitric, hydrochloric, you need to know what they are. And if I give you an ionic formula like that, you really should be able to work out the fact that it's NaOH. So, when we react an acid and a base, if the base is an oxide or a hydroxide, we're going to get salt plus water. So the H's and the OH's combine to form water. As before, the anion from the acid goes with the cation from the base to give us our salt. Now, this is a classic neutralisation reaction. We can write an ionic equation for this by leaving out the spectator ions. So the sulfates and the sodiums, they start off aqueous, which means they're floating around freely and independently. They end up aqueous, floating around freely and independently. So we can leave them out because they're not actually involved in the chemistry, and that actually gives us H plus OH minus equals H2O, or probably slightly more formally correctly, H3O plus OH minus gives 2H2O. Okay, so writing these equations. So what's happening? We're reacting potassium hydroxide with sulfuric acid. Well, first thing we need to do is see that potassium hydroxide is your classic hydroxide base, sulfuric acid is an acid. So what have you got? You've got acid plus base. And we know that reaction scheme turns into, gives acid plus base, gives salt plus water. Now, we need to be able to write our formulas, of course. So sulfuric acid is H2SO4, potassium hydroxide is KOH. Now, to work out the products, well, you know what water is. So the H's and the OH's combine to form water. So the salt's going to be the potassiums combining with the sulfates. Now, you know potassium is 1 plus. You know sulfate is 2 minus. Therefore, you're going to need 2 potassiums with every sulfate. K2SO4. Of course, because it's an equation, we should put in states. And that's what we'll end up with. Oh, and we've got to balance it, of course. Now, balancing it. And what do we see? They're usually pretty simple to balance, so look for the twos. Look for what we've got in the salt. So we've got 2 potassiums here. That means we're going to need 2 potassium hydroxides. Once we get 2 hydroxides, every hydroxide combines with a H plus to give H2O. So once we've got 2 OH minuses, going to react with the 2 H pluses to give 2 H2Os. As I say, we chuck in states. Next one, HCl, hydrochloric acid reacting with zinc. Okay, HCl is clearly an acid. Zinc is a metal, so this is acid plus metal, and we know the scheme goes, acid plus metal gives salt plus hydrogen gas. So, easy chemicals to write the formulas of, it's going to be zinc plus HCl. The H's are going to end up as hydrogen gas, so the salt's going to be zinc cations with chloride anions. Zinc is 2 plus, chloride is 1 minus, therefore we're going to get zinc chloride. Now this time look for where the 2's are, so we've got 2 Cl's and 2 H's, so that means we're going to need 2 HCl's, it's going to balance out pretty simply. The last one of our examples, nitric acid, this time reacting with a carbonate. So acid plus carbonate gives salt plus carbon dioxide plus water. So zinc carbonate, zinc is Zn2 plus, carbonate is CO3 2 minus. So ZnCO3, nitric acid, again one you should know, HNO3. Now this time, the salt is a good place to start. So the Zns are going to combine with the nitrates. Nitrate is 1 minus, that means we're going to need 2 of them to give us our zinc nitrate. Now, every carbonate ion needs 2 H pluses, and when you get the 2 H pluses with a carbonate, it very simply breaks down to CO2 plus H2O. Only thing we need to do to balance that, we've got 2 nitrates, we need 2 H pluses, therefore we need 2 nitric acids. And that's what we end up with. So, do those questions. And then